Okay.
J equals pi d4 then, because it's a solid shaft.
Yes, we can. So we can find J, can't we? Well, do we need J? That's the question. Maybe we do, maybe we don't. We're after theta. The first thing to do is to look down, it's to look for what we know, write down what we know, and then what we want to find, and then look for a formula that will allow us to find it. Well, theta, which is what we're after, applies in, comes up in the torsion equations. If we write down the torsion equation, there it is. So we're going to need to know this ratio. This ratio is going to be one that we're bound to have to use because it involves theta. So that means we need G and we need L, the other two things that are in that ratio. And then we're going to need one of the other two. So, Paul, that's where you ask yourself the question, well, this ratio involves J. That ratio also involves T, the torque, but the other ratio involves the stress, torque, no, not torque, what's the word I'm looking for? Yeah, but what's the word for it? Maximum tau stands for stress, yeah, the shear stress induced. So that's, we know that. And R, do we know R? Yeah. So we can find R, can't we, because we know the diameter. So which ratios are we going to use, do you think? The first and second? Second and third, yes, second and third. We must use the third because that involves theta, and actually we know that, and we know that. So in fact we don't really, although we could work out what J is, we don't need to, because we don't need this ratio. So we write down what we know and put it in the correct units, and then we rearrange this for theta. So how am I going to rearrange this for theta? If G theta over L equals tau over R, rearrange for theta. What do I do? So how, Jack? Algebraically, what do we do? Okay, times both sides by the length, so that the lengths cancel. I'm reminding you of the basic rules here. Times both sides by the length, that means they cancel. So the length comes up here. G theta equals tau over R times the length. And now what? Divide both sides by G. Theta equals tau times the length over R times G. Remember, we can separate them or we can write it all over. Tau L over, all over RG. So now all I need is these values, and I can get them. I've got all that information. So I'll just pause this while you just finish that off. So putting the values in: length 1.5, diameter 500 millimeters, which is 0.05 meters. Tau max, what's that? Do I need to do anything with that? Yes. Meganewtons times 10 to the 6. So that when I put it into the calculator, I must remember that it's a meganewton, newtons per square meter. What's G? 80 giganewtons. Square meter. So what do I do with that? 80 times 10 to the 9. Giga times 10 to the 9. So now I've got the values I need. Well, I've got to do something with that to get R. So R is going to be half of that. And then I can put the values in, and out will come the answer. tau 70 times 10 to the 6 times the length, which is 1.5, was it, over the radius, 0.025 times g, which is 80. Yeah. And that's what I key into my calculator. So what does theta turn out to be? Sorry, 0.0525. Unit? Radians, not degrees, radians. It gives you the angle in radians. How would I convert it to degrees? How would I convert it to degrees? To convert, remember, Lee was telling us, 360 degrees, this is something else to remember, is 2 pi radians. That's the thing to remember. It's not on your formula sheet, add it. So that means that 180 degrees is pi radians. So how do I convert? What do I do? What do I need to know? If pi radians is 180 degrees, what would be handy to know? So if I divide both sides by 180, I'll get 1 degree equals pi 180. Is that what I want? I want to know what 1 radian is, don't I? So it's the other way. 180 over pi is 1 radian. So times this 0.0525 times 180 over pi will tell us in degrees. So it's about 3 degrees. This is why I go into high falsetto and do a little song. Quick recap then. So what do? What do we want to find? First thing I look for in these sorts of things is, what am I after? Find the twist. So I'm after the angle. What do I know? I know the length, I know the radius and I know the diameter, so I know the radius. I'm going to have to do something about the units there, I say to myself. I know the torque, well that's in meganewtons, and I know G, the shear modulus, is 80 giganewtons per square metre. Then I think about my torsion equation and look for the ratio that includes what I'm after and the ratio that includes what I know or I can find. So I'm going to ignore one of these and I'm going to choose to use that one because I know nothing about the torque. And then I just rearrange it, put in the values that are in the right units, and out comes the answer. And if I'm interested in the angle of twist in degrees, I need to do a little conversion to get it to degrees at the end.